For a non-zero complex number z, let argument of z denote the principal argument with argument z greater than minus pi and less than equal to pi. Then, which of the following statements is or are false? So this is a multiple answer correct question. We have to evaluate all the options here. So we will start with the first option, which is A. It says argument of -1 minus I is equal to pi by 4, where I is equal to root of -1. Argument of -1 minus I is what? We need to find out the answer of this question. It's easier if we solve it graphically because we do not need any formulas in that case. For solving it graphically, we will draw the coordinate plane. The x-axis is the real axis and the y-axis is the complex axis. We'll label these points as real and the y-axis as complex. Now, we will find -1 minus I, which can be treated as a vector. If we label the coordinate axis, then the intersection of the real and complex axis is taken as origin. The right hand side of real axis would be taken as 1, 0 and the left hand side is -1, 0. And the positive y-axis is taken as I, and so it can be written as 0, 1, which denotes the point 0, I on complex axis, and this can be written as minus I, which is 0, -1. Or we can write it as 0, I and 0, minus I. Now we have the vector -1 minus I. -1 minus I is this point. Can be treated as this vector. We need to find the argument of this vector, which is nothing but the green shaded region. This is the argument of z. We can find the value of this if we know the value of the white region, white shaded region, and we know the value of white shaded region from the tan formula. We can use, if the white shaded region is theta, then we have tan theta, and we only take the magnitude in this case. Means the value of angle theta and not considering it with sine, because we can assign sine at the after solving, because we know that the principal argument lies between minus pi to pi. We have tan theta is equal to perpendicular by base, which in this case is equal to, the perpendicular is P here and this is the base. The perpendicular is 1 and the base is also 1. We take the magnitude only in this case. That implies theta is equal to pi by 4, because tan of pi by 4 is 1. So the value of this angle theta is pi by 4. Then the mod of argument of z is equal to pi minus pi by 4, which is equal to 3 pi by 4. But as it lies below the real axis, then we take the argument as negative. Hence, argument of z is equal to minus 3 pi by 4. That implies option A is false. Now we evaluate the second option, which is the function f from real number to minus pi to pi, minus pi open and pi closed, defined by f of t is equal to argument of minus 1 plus it for all t belongs to real number, is continuous at all points of real number where I is equal to root over of minus 1. It would be, this can be also solved graphically, but here we have to take two cases. One where t is greater than 0 and one where t is less than 0. We consider the first case, B. Case 1, t is greater than 0. Then drawing that on the coordinate axis, we get the vector as, this is for case 1, we have f of t as argument of minus 1 plus it. This is considered as real axis r and this is considered as complex axis. We denote this as the intersection of both the axes as 0, 0. This can be treated as 1, 0 and the left side of the real axis is minus 1, 0. And this is treated as it. So it can be written as 0, it. Because t is greater than 0, so it lies on positive y-axis and this is 0, minus it. We have the point as the intersection of lines from both these points. This is the vector and the yellow shaded region is the argument of z. We can find this by finding the value of the blue shaded region, which we consider again as theta. If we take tan theta is equal to perpendicular p by base, which is equal to, the perpendicular is mod it divided by base is again 1. Then this is equal to t. That implies theta is equal to tan inverse of t. We write mod of it as t because the mod of I is 1 only. That implies mod of argument z is equal to pi minus tan inverse t. And we know that when it is above the real axis, we take argument z as positive. So argument z is pi minus tan inverse t. For t greater than 0, we must not forget the condition that we are using in this case. Then we have to make a case 2 for option B. Option B, case 2, which is t less than 0. We have f of t as argument of minus 1 plus it. When t is less than 0, the point I comma t is lies on the minus y-axis. We again draw the graphical plane. This as the y-axis, which is the complex axis, and this as the real axis. We'll denote this by r, this by c. The origin is 0, 0. This is 1, 0. And the left side is minus 1, 0. We have argument of minus 1 plus it. The it term here would lie on minus y-axis. This is 0, it. This is 0, minus it. Because we considered t as less than 0. The vector formed is the intersection of both the lines. This is the vector that formed. Again, we have the yellow shaded region as the argument of z and we have the blue shaded region as something theta, whose value we can find by using the tan formula. Now, tan theta, we only considered the value of the angle and not the sign. Tan theta is equal to perpendicular by base, which in this case is equal to, the perpendicular is t and the base is t and the base b is equal to 1. we have P by V is equal to T. That implies theta is equal to tan inverse of T. Now, we take argument Z mod as pi minus tan inverse T. But as the angle lies below the real axis, argument of Z becomes minus of mod value, which is tan inverse T minus pi. And we must not forget the condition T is less than 0. In first case, we got pi minus tan inverse T. We require another. In first condition, for T greater than 0, we got argument of Z is equal to, where Z we considered argument of minus 1 plus IT is equal to pi minus tan inverse T when T greater than 0 and tan inverse T minus pi when T less than 0. At T is equal to 0, we have to check the continuity because it is continuous at every other point other than T. At T is equal to 0, we have f of T as pi for the T greater than 0 part and minus pi for T less than 0 part. That implies it is not continuous at all points. At x is equal to 0 or we take T is equal to 0. That implies option B is also false. Now we have to find the value of option C. We have for any two non-zero complex number Z1 and Z2, argument of Z1 by Z2 minus argument of Z1 plus argument of Z2 is an integer multiple of 2 pi. This is a rather simple question. We have option C as argument of Z1 by argument Z2 minus argument of Z1 plus argument of Z2. And when these lies in the principal argument value, we have argument of Z1 by Z2 as argument of Z1 minus argument of Z2. That implies the equation changes to argument of Z1 minus argument of Z2 minus argument of Z1 plus argument of Z2, which is nothing but the value is 0, which is a multiple of 2 pi. That implies multiple of 2 pi. That implies option C is true. We have one last option, which is option D. According to question, we have for any three given distinct complex numbers Z1, Z2, Z3, the locus of the point Z satisfying the condition argument of Z minus Z1 divided by Z minus Z3 into Z minus Z2 divided by Z2 minus Z1 is equal to pi lies on straight line. We'll again use the formula that we used here, which is in this place, the formula that we used here. We'll again use that here. We have according to given question, we have argument of Z minus Z1 into Z2 minus Z3 divided by Z minus Z3 into Z2 minus Z1, which can be written as argument of, we'll separate the Z minus Z1 and Z2 minus Z1 terms together, which is these terms, and we'll separate the other two as 1. This can be written as Z minus Z1 divided by Z2 minus Z1 into Z2 minus Z3 divided by Z minus Z2 is equal to pi. That implies it can be written as, we can separate the two parts. We have a formula. We'll write the formula here. Argument of z1, z2 is equal to argument of z1 plus argument of z2. That implies this can be written as argument of z minus z1 by z2 minus z1 plus argument of z2 minus z3 divided by z minus z3 is equal to pi, which is nothing but implies z, z1, z2, z3, they lie on a concyclic quadrilateral. This is the equation of a concyclic quadrilateral. Lie on concyclic quadrilateral. That implies z lies on a circle. The locus of z is a circle. That implies option B is false. At the end, we found that of all the given options A, B, C, D, we have option A as false, B as false, C as true, and D as false. That implies the answer to this question is A, B, and D.